Thanks everyone so much for joining us today. We're really excited to have Vijay from AWS joining us. He's a very accomplished senior solution architect with a very formidable background in the enterprise blockchain space and enterprise networking space. So just to give everyone a quick high-level agenda of what we're going to go through today, we're going to kind of do a two-part presentation. Vijay is going to lead us off, take you through a bunch of slides talking through VPCs and PrivateLink and networking best practices. I'd encourage everyone to use the chat or use the Q&A or raise your hand. We want these to be as interactive as possible. After he wraps up his stuff, I'm going to actually take you into Kaleido, and I'm going to put some of those pieces into action. Specifically, we'll show PrivateLink in action, show how you can customize your Kaleido node with different ingress layers. You can make it private only, you can make it public only, or you can make it a hybrid node. We'll show how you can use AWS KMS for two things in Kaleido: for master encryption of your disk, and then to actually store your Ethereum signing keys, and then either use a Web3 library or use Kaleido's easy transaction submission button, REST API gateway to simply and securely send those payloads in. The takeaway of what I really want to accomplish today on my side, though, is as a fully managed service at Kaleido, we're very conscious of the fact that you have existing cloud infrastructure, and we want to delegate the ownership and the autonomy of your node and your resources as much as possible. So whether that's the master encryption of the node, whether that's your transaction signing keys, whether it's backups for business continuity, different networking paradigms, IAM integrations for role-based access control, we've put a ton of work into the product for you to very seamlessly and elegantly integrate with your existing estates. Specifically, what we'll show you today is a lot of the services that you're likely already familiar with in AWS and how those can be very easily woven into Kaleido. So we'll be focusing on this portion down here, the member plane, where you can take extra control and add extra security, extra customizations to your runtimes and to your nodes in Kaleido. So gonna skip the vast majority of the slides today. I know Vijay has some, and I'll show everything in action. So we should have a good combination of slides and showing Kaleido. Again, this will be recorded. Please don't hesitate to ask questions, and we'll go ahead and get started with Vijay. So I'll stop sharing and turn it over to Vijay for a deeper introduction and then the subject matter material.
Hey, Nick, thanks. Guys, excited to be here again with another awesome Tech Tuesday. So I'm going to share my screen. So let me know if you can see my screen.
Yep, looks good.
Okay, my presentation.
Yep.
Okay, I'll jump right into the presentation. So we'll talk about securing blockchain communications in the network, and also how compliance can be a very integral part of the communication when we talk about network-to-network communications. A little bit of introduction. I'm a senior partner solutions architect on the blockchain segment. I support a bunch of global ISVs. Kaleido is one of the preferred partner that I work with very closely. Have 25 years in the industry. I'm pretty new to AWS. Prior to AWS was with IBM Blockchain, leading the North America practice from the architecture side. I can say pretty much doing blockchain and DLT for 5 years. Like most of you, I did start with mining way back when things were like in the gray when we talk about blockchain. Built quite a bit of networks on the enterprise side, 24 plus, and handle more than 100 use cases in the space. Happy to be here, and let's jump onto the content. So what are we going to cover in this quick session? So we'll try to have a very quick recap, maybe 3-minute networking overview. So you have the context that we're going to talk about the subject, and we'll talk about AWS PrivateLink and some benefits and how it works, and how do you create a private link using console. Then definitely some blockchain related examples how private link can be applied and make your life very easy. So going into the fundamentals of VPC, the first topic that comes when you talk about VPC is the VPC itself, which will have availability zones and subnets. So availability zones are two or more zones with multiple data centers for a high availability scenario, and your subnets are, think about public and private partitions, virtual partitions inside those zones to make your applications or networking communicate to the internet or in a private way. So these, concepts or tools or components are a must. If you have to start using PrivateLink, and you need to understand them at least at a very high level. Next one on the line is routing or routing. So if I'm talking about routes or routes, I mean the same thing, different pronunciation. So even though PrivateLink doesn't involve much of routing, but we still need to understand routing from a networking perspective and how it plays a very important role in what VPC talks to, which are the VPC and some of the AWS services that you want to restrict communication with. So on top of route tables, we do want to authorize traffic flowing in and out of the network. So for that, we use security groups. And we can use security groups with private links. So that's another reason why security groups are very important from more like a virtual firewall for your communication to flow in and out of private link. Elastic network interfaces. For guys who do not know what is an ENI, if you're used to the old desktops or the newer desktops, you will find something like an elastic network adapter, where you just plug in your Ethernet cable or your USB cable to it. So this is a virtual device on the AWS side, which will help you, get a private or a public IP. And ENI are the very integral part of AWS PrivateLink. And whenever we create a private link, it does, create an ENI through which, we can communicate to the network. So that's your quick AWS VPC fundamentals. Let's talk about some of the benefits before we go into really talking about what is private link and how to create them. So it's really secure. It's really simple to manage, from a network management perspective, and we'll see why. And also, you can speed up your on-premises to cloud migration, or if you have something that's running from your on-prem, need to access a cloud service, then AWS PrivateLink is one of the ways you can do it. So a little bit more details on what is secure from an AWS PrivateLink perspective. It uses private IP connectivity, so which obviously means that the traffic is not going to traverse the internet, so which is a pretty good thing. And use security groups to authorize the traffic that flows in and out of your network, especially from a VPC to VPC communication. So that pretty much takes care of your network communication stay within the AWS network, not traverse through the internet, and still have controls with security groups on what services communicate to what. Simplifying your network management happens in a number of ways. Right now, if you need to connect to a service that is running in another VPC without using private link, you definitely need to configure a bunch of things in your network. You need an internet gateway, you need a DAT device, you definitely need a public address. You can prefer to choose a local network, but still need to do the route table configuration and maintain them. And if you decommission a service, you need to go back and then maintain the route table and whatnot. And it's a network management overhead as well. What if we have to share services between two different accounts, two different regions? That adds another level of complexity in the network management. So with AWS PrivateLink, we don't have to do anything. We just create the private link, which will give you an endpoint. You just share the endpoint to the consumer, and consumer just uses that endpoint to connect to the VPC and the service. So what's good about cloud migration, or how do you access something from your on-prem to the cloud or from the cloud to an on-prem, right? This is a a pretty solid requirement from when it comes into a blockchain-based implementation, especially with government agencies or large-scale banks or regulatory compliance, based institutions. We do have significant, regulation in place and compliance in place for HIPAA, PCI data, or even PI information lately. Cannot traverse through internet, and that's been a mandatory requirement in any use case that I work with from a regulatory compliance side. Any on-prem to AWS cloud, you can use, or if you have a direct connect, and that's the only thing that you need to have to establish a secure connection between an on-prem and AWS cloud. Then what you need to do is just provision your private link to this service from the cloud console, and provide that service endpoint to the users. Or if you're working with multiple groups within your organization, and they can use that endpoint service to connect to the cloud in a very secure way. And the traffic again does not use internet to communicate because it's using the AWS Direct Connect. So these are some of the core powerful features from an AWS PrivateLink perspective. Let's talk about what are VPC endpoints. So there are two types of VPC endpoints. One is gateway endpoint, the other one is interface endpoint. When we talk about gateway endpoint, that means when you create an endpoint, the communication does go via the internet to the service. The interface endpoints are nothing but the private links, which uses the internal ENI concept that I described before, so that they stay within the AWS network and uses the private IP for communication. So this session, will pretty much cover only the VPC endpoints or the AWS private link, which is internal to the AWS network. We'll not talk about the S3 and DynamoDB, which are the other two gateway endpoints that is available with AWS Cloud. So this is a typical VPC architecture. Two availability zones. There are two instances on each side for high availability. And if you want to create a private link from these two availability zones for these instances to talk to any of the AWS services listed above, what you need to do is just create a private link, and the private link will enable the ENI interface to have a private IP through which you can securely communicate to any of these services. We have 100+ services supported right now. We started with somewhere like 45 initially, then 80, then 95, then now we have like really 100+ services. Even S3 has a facility to create a AWS private link, so you don't have to communicate through the internet for S3 as well. Again, no route table configuration is required. As you can see here, the route just has only the local IP mapping here. We don't have to really create and maintain any kind of route table information. So let's go into the console and see how we can create a private link. Just going into the console. This is one of my accounts here, and going into a VPC and go into endpoints here. And you can see I have a couple of endpoints running here. So this first endpoint is a managed blockchain service AMB from Amazon, and this is a secret manager. So there are three types of endpoints you can create. One is to any AWS services. As I mentioned, it can be a gateway interface or an interface endpoint. Then if there is a service that you have created in another organization or another account within your AWS account, and you want to access that using private link, then you need to have a fully qualified name here to find the service. You just get the service endpoint name, and then you just verify that, and you get a private link there. The third option here is, if you want to connect to a third-party service or a marketplace offering which has a private link, then you can actually find that marketplace service here, and then start creating an endpoint to that. So when you talk about marketplace, we do have AWS Marketplace PrivateLink URL. So here, it clearly shows you how to create a private link, and if you are a provider, and make your SaaS offering, available through a private link, or if you are a consumer, how to actually consume a service via the marketplace. As you can see here, Kaleido is also listed here as a SaaS offering private link partner. If you click on Kaleido, the first thing you need to do is, continue to subscribe. And once you continue to subscribe, you can see, Kaleido appearing here if you do a search. So then, it's pretty simple. Then Kaleido will enable you a private link subscription. Then you can start using the endpoint service in your application. So this way, from your VPC, you're directly communicating with Kaleido's VPC. You're not traversing to the internet. So these are the three ways you can create, VPC endpoints, especially from a private link perspective. Let's get on to some more information. So how does private link work again? So this covers pretty much everything that we talked so far. If you are in a on-premises firm or on-premises data center, then you use Direct Connect to connect to AWS cloud environment. And if there is an Amazon EC2 instance that needs to talk to an AWS service or a service on the marketplace, or your own service in another VPC, then you create a VPC endpoint. And one of the requirements is to have a network load balancer in the front to talk to these services available. That's for the high availability and other load balancing requirements that we have. So this is actually pretty simple. So let's talk a little bit in depth about some of the core networking concepts and where AWS PrivateLink stands. So a typical VPC architecture, so with some sample route tables. For example, if instance A need to talk to or communicate to internet, so the options that we have is you provision IGW internet gateway, and then you add a corresponding route table configuration. As you can see here, the Elastic network interface provisions a EIP, a public and private IP address through which you can communicate to the internet, as well as the other AWS services. The same thing if you have to do from a private subnet, using a NAT instance, for example, you need to definitely add a route table configuration, and the instance C will communicate through the NAT instance via the internet gateway and talk to the corresponding services or through the internet for other communication purpose. The better way of doing that is using a NAT gateway. So again, simply change the route table configuration and you're good. So let's talk about VPC endpoints here. So VPC endpoints are pretty easy to create. You go into your VPC, into your console, pick up the VPC and create a VPC endpoint. So in this case, if you're creating a gateway endpoint using the VPC, then you need to add your route table configuration to communicate to S3 as well as DynamoDB. So here in this route table configuration, we are just seeing only the S3 and not the Amazon DynamoDB. So extending this architecture further into communication to an on-premises space, VGW virtual gateway, and then you have a VPN option to connect to your on-premises, or an AWS Direct Connect with Direct Connect gateway for highly available and secure communication. So use a vendor to actually subscribe to the Direct Connect, then your network connection to the on-premises is established. So now if the instance A need to communicate to this on-premises, or the on-premises needs to communicate to the instance A, it is possible just by adding corresponding route table configuration to enable the communication. So as you can see, this is getting really complex, but you'll see when we complete and how complex it can get. So what if we have to communicate with multiple VPCs? We can use VPC peering. There's a lot of advantages when we talk about VPC peering. The VPC can be within the region or within outside the region as well. And again, the route table is what just you need to maintain to enable this access to this VPC. The next is transit gateway. If you have to connect multiple VPCs together, including an on-premises location, then you start using transit gateway to communicate to these VPCs. Again, maintain a route table configuration here. So then comes our private link, AWS PrivateLink. If there is a service that's available in another VPC, you create an VPC AWS PrivateLink and start using that private link. And as you can see, there is no route table configuration needed here. And you can use the same private link to talk to another all the AWS enabled private link services with AWS Cloud. For debugging and network traffic monitoring, you enable VPC logs, and VPC logs can be sent to CloudWatch or S3 for backup purposes for further debugging or maintaining information. So all this is powered by AWS Global Accelerator. So I'll recommend read about Global Accelerator. It's a pretty a sleek way to make sure a lot of this communication doesn't go via the internet and uses only the AWS private network. And what we are focusing today is just one big part of the the network puzzle, which is the AWS PrivateLink. Let's jump into some blockchain examples with AWS PrivateLink. So this is a Fabric client with a Hyperledger Fabric client, running in a VPC. And this is an example of how we can connect a Fabric client talking to AMB or Amazon Managed blockchain running in an AWS account. It could be in the same account or a different account. So so what you do is create a VPC endpoint or AWS PrivateLink, and then use the service endpoint to actually talk to the AMB from the Fabric SDK. What you'll do here is use the endpoint in your connection profile to actually start communicating with the Amazon Managed blockchain. This is one of the simplest example where we are seeing directly connecting to an AWS service using a private link. The second example, it's a Corda example. So how do you interact with Corda Notaries in a different VPC? For example, a notary can be a offering that a third-party company provides, or you want to run all your Corda Notaries in a separate VPC for isolation. Then you have your party account or party A's account, where the Corda network needs to communicate with the notary to enable transactions going into the notary for finalization or consensus. Then you do create a VPC endpoint pointing to a network load balancer on the notary VPC, and the network load balancer will actually enable communication with all the other notaries in the account. And the communication becomes simple again, because again, using your connection profile or your configuration, just use the service endpoint to talk to the notary. So this again is possible using different accounts, different regions. The one requirement is you need to have a elastic load balancer in place for the communication to happen. So let's talk about a little more complex setup here. So if you are a business network operator, or something that I see in the industry picking up pace from large scale consortium based network operations. So if you are a business network operator governing or maintaining a consortium based blockchain, and there are end users or your consortium based users connecting to the consortium based account, and using an application to talk to the blockchain, they can still use an endpoint, using a private link and communicate to the blockchain VPC, which is in a different account. And also from a network operator side, as a BNO, you can actually isolate all your management related activities, right from backup recovery, metering, monitoring, alert management, patching, downloading data, reporting, whatnot, using a separate management VPC, which is going to be a complete isolation. And the good thing about it is, it does not need to traverse the internet from a communication or network requirement. So this all stays internal. And what happens, for some reason, if there is a failure or some kind of an outage in this application, your blast radius is also controlled only with this particular VPC. You'll be still able to manage your network from a BNO perspective. So these are some of the basic examples from a blockchain perspective. And one of the questions that I frequently get from the blockchain enthusiast is how does AWS PrivateLink help in a Kubernetes cluster environment, or how do I communicate with the Kubernetes in case this particular VPC here is my management node for Kubernetes, and I do operate from this particular VPC to the connect to the other VPC which is running my Kubernetes. It's again the same general concept here. Create an endpoints in a VPC endpoint here, which is AWS PrivateLink. Connect it to the network load balancer by default, and that'll give you a service endpoint. Using the service endpoint, you can actually start using a command line interface or SDK or custom written application running in this EC2 to talk to the Kubernetes cluster. So this is some of the basic information that I can share from an AWS perspective in the blockchain world. Again, some of these examples are pretty basic. Your networks could be pretty complex. From a production perspective, maybe something close to the VPC animated slide that I showed you. But this is the core concept. If you have compliance requirements, if you have requirements where your network data cannot traverse the internet and needs to be secured in a controlled way, you need to have the VPC to VPC communication, both internally as well as from account, as well as from cross-region, as well as from on-prem to AWS cloud. So PrivateLink is one of the best options that we have. So I will share some of these links here I specified in the chat once Nick takes over, and I'll be happy to answer any questions over the chat. Nick, what do you? So hope this information was useful to you guys, and you can definitely reach out to me via LinkedIn. If you want to chat further on some of these topics, I'd be happy to help you. Over to you, Nick.
Super. Thanks so much, Vijay. Always fun and very edifying to learn and listen to subject matter experts. So I'm going to start putting some of this into action then. So can you see? Just confirm you can see my screen. Okay. Yes.
Yep.
Okay, super. So as I mentioned at the outset, we've done a bunch of work in Kaleido, trying to extend control of the runtimes and of your application tier to the end users and to the organizations. So here we can see a quick snapshot of sort of some of the runtime integrations that we give you right out of the box that are very, very easy to configure. You'll see that here in just a second. So private networking using PrivateLink. This is not a binary choice in Kaleido, which is very useful. You can choose to have a private only ingress. You can choose to have a public only ingress, or you can compartmentalize your workloads. Maybe you have sensitive data, PII that, financial data that does need to, not travel through the internet, stay on the AWS backbone. That portion of your application can leverage PrivateLink. Maybe you have some more public data, sort of innocuous key value pairs. Those could target, sort of the public ingress for your node. And we'll take a look at that. Backups, we're not going to touch on these today, but these are really, really important. So, one of those InfoSec requirements, as everyone knows, is always the dude, where are my keys question, and then the business continuity question, right? What if this managed vendor goes away? How do I have, that guaranteed unequivocal assurances that, I have the full snapshot backups of all my data And with blockchain, that's really important to have those low-level signing keys that are either going to participate, in transaction signing if they're held on the node, but specifically in the consensus algorithm. Of course, you also get the full level database, which has all your world state. Log streaming, this is nice to get your Geth logs or get your, Tessera logs, get your REST API gateway logs from Kaleido, and you can start marrying what's happening, at the low level, at the runtime level, alongside your application. And then key encryption. There's, as I just mentioned, there's some really important things that, the node has and that are stored on disk. Of course, Kaleido, we follow all best practices and we do encrypt that material. But again, there are often times where there are InfoSec requirements for you to be the root admin and the true sysadmin and have, control of another master key that gives you extra encryption. So this is the first one that we're going to look at today. We're not going to go super in depth into some of these other features, but I just want to draw your attention to a few other integrations that are available alongside AWS. One really, really awesome one that we've introduced into Kaleido is around application layer role-based access control. So basically putting a firewall in front of your node, creating different rule sets, dictating, what certain calls are allowed to be made, what keys need to be signed with. And you can seamlessly integrate with your existing IAM instance, your existing user directory in AWS, and you can do a basic OAuth flow. You can have them authenticate, into your LDAP, into your server, swap them for a token, and then use that token to authenticate into Kaleido. And inside of it, it's going to have some nested rules about what you can and what you cannot do. The other thing that we're going to look at, which gets a bit closer to the transactional layer, is integrating with Cloud HSM features or KMS features. So this is another really important InfoSec requirement of, keeping the custody of those keys in the most security compliant device, whether that's a HSM cluster or whether that's a KMS service. And on Kaleido, we actually allow this to function with whatever sort of implementation of your application you've designed, whether that's a raw Web3 application or whether you're leveraging the Kaleido Easy button, our REST API gateway for basically codeless programming, basically just basic web programming and sending simple REST calls. So Kaleido will do the intercept of that unsigned object, authenticate into your KMS instance or into your HSM cluster, create that proper fully signed object, sequence it if you're using the REST API gateway, and then submit it into Kaleido. So we're going to look at the two KMS flavors, holding the key that's going to sign Ethereum transactions, using a master key to encrypt your node, and then we'll show those in action using PrivateLink. So that's the table setting here in Kaleido, and now I'm going to jump in. So let me extend the session. And so I have two networks inside of my account. I just have a placeholder network that we use for demos, and then I have a new network that I created that I named PrivateLink, Encryption, and KMS. So I'm going to hop into my environment inside of Kaleido. I only have a single region whitelisted here. We've covered this in the past, but one great thing about Kaleido and about AWS is there's this fantastic infrastructure and support for multiple regions, multiple AZs around the globe. So as your Kaleido network decentralizes, as it grows, as it truncates, you can bring on additional AWS regions. Maybe you turn into a global network and you need support for Europe, for example, or you need support for APAC regions, Sydney, Seoul. You can continue to whitelist these regions, and then you can deploy nodes, deploy runtimes, deploy your hosted services into those regions. So I'm just going to leave it as AWS US East, since I'm based on the eastern seaboard of the coast, and that's all we need for today. So I'm going to hop into my environment, called it PrivateLink Test 1, and we see here that we have two nodes that I've created. Node 1, I've added a public and a private ingress, and node 2, it's a private ingress only. So it will only be able to be communicated from using PrivateLink. We'll come back to these and look a lot more deeply at those configurations, but let's start by just creating a new node, because we want to look at that low-level disk encryption. So I'm just going to call this guy node 3, and we'll just put encrypted inside of parentheses here. We only have one region whitelisted, as I mentioned, so that's an easy choice. And I'm just going to make it a small node that's going to be a validator, participate in the algorithm. So this guy will take, 20, 30, 45 seconds to fully initialize and join the network. We've all looked at this in the past ad nauseum, so I won't bore you with this screen watching, the GraphQL update in real time. Instead, what we want to look at is a bit more detail about how that master key encryption works. So we'll go back to this screen right here, and we'll just take a look at the architecture here. So essentially what happens is there's two flows. The key is going to be generated in memory only, and then the call is going to be made into the AWS KMS service to use your master key, some sort of symmetric key or asymmetric key that supports encrypt and decrypt, and that's going to be stored on disk. So anything persisted to disk, if you've integrated with this KMS service with key encryption on Kaleido, is going to be fully ciphertext, only unlockable, only decryptable by your master key. When the node starts up, that same call is made and the key is persisted in memory only. So that's very high level architecture of how this works. And now we can go ahead and take a look at it in action. So what we've done in Kaleido is we've actually decoupled the configuration objects from the runtimes, because we've noticed that there's a lot of scenarios where things change, right? Maybe you want to update your configuration, maybe you want to apply a new configuration, detach a configuration, all sorts of circumstances. So we've made it very easy to separate sort of your configuration management and your runtime management. And you can see all of the available options at the very bottom of your environment navigation under cloud configurations. So the first thing I'm going to do is I'm going to go ahead and click on this key store. And what we need to do first is we need to make our master key encryption object. We need to teach Kaleido about some stuff that's sitting in our AWS account. Specifically, we need to teach Kaleido about an IAM user that has permissions to talk to a KMS instance. So I'll start populating these, and then we'll dig into AWS and see how everything marries together and how the relationships are mapped. So we'll call this KMS node encryption config. Try to go with intuitive naming conventions here. And we see that Kaleido is asking for 4 arguments to populate this configuration object. We want the region of where our KMS instance is located. Conveniently for me, mine's also in US East 2, the exact same region where I've deployed these nodes. It wants the user ID or the API key for the IAM user, the associated secret, and then the ARN for your master symmetric or asymmetric key, anything that can do encrypt and decrypt operations. So I already know this one. This is US East-2, and then we can start grabbing all of the other fields that we need. So here's my user. I only have a single user inside of my IAM instance, Kaleido test user. And we see that, I have my access key ID right here, and I have my secret stored. One thing that's important here, whether we're talking to KMS for transaction signing or whether we're talking to KMS for the node encryption, of course, are policies. So I took the easy route and I just went with super user policies right here. So gave it everything. But this is a really important, sort of scenario. And again, this is really important, in terms of, InfoSec. So what you need for disk encryption is you need 2 permissions, and they probably are as intuitive as could be. You need encrypt and you need decrypt. If we're doing transaction signing, you need get and list so that Kaleido can, list the key information, derive that Ethereum key, and then you need sign and verify. If you want to cheat and take the easy route like I did right here, you're going to get all of those for free. But these are documented in Kaleido, and if you are familiar sort of with the basic functionality of what we're trying to do here, the permissions themselves are quite explanatory. So there's our user. We've applied that permission. And then we can go ahead and look in our KMS instance and we can grab that ARN. So I'll go to my KMS service right here. And we see that I have 2 keys. I have a Kaleido master encryption key, and then I have a Kaleido Ethereum signing key. And as you're creating the key, you're going to be asked to make some choices, specifically the spec or the configuration. I just went with the basic symmetric default for my encryption key, but you can also use RSA keys if you want. As I mentioned, the only mandate is that it supports encrypt and decrypt operations. And so that's really, really straightforward inside of the AWS dashboard. There is a specific choice you do have to make for the Ethereum key, which probably goes without saying, and we'll look at that in a second. But for the master key, you can go with symmetric default, or you can just take an RSA key as long as it supports encrypt and decrypt operations. So this is what Kaleido wants right here, the identifier. So I'm going to copy that, and I'm going to paste it right here. And then I'm going to use my Google Doc and grab the other two fields that we need. So we need my API key, and then we need that secret. And this isn't very exciting. This is us just literally creating a JSON configuration object behind the scenes, teaching Kaleido about all of the AWS details that Kaleido needs in order to make these calls on your behalf, in order to authenticate proxy into your AWS account. So go ahead and click finish, and we see here that it just immediately creates that object and that it's inactive right here. So let's go back to our blockchain, make sure our node has come to life, and give this a refresh since it didn't refresh automatically today. This guy has started, probably started in 20 seconds or so. And now what we can do is we can go back to that configuration object that we created. We can click into it. We see the details that we just populated right there. And now we can attach a runtime to it. So what we want to do is we just want to choose node number 3, the guy that I just created. So I'm going to go to node number 3 that I called encrypted. It wasn't encrypted until we did this. So now I've applied it, and now I need to reinitialize the node so it can do those networking things that we just looked at. So I'm basically bringing this node back to life here. So we see that it's not applied. And what I want to do is I want to go ahead and click apply config. And this is just going to do a reset. It's going to reinitialize the node, and the node is going to rejoin your blockchain environment. One thing that's quite cool to do that I didn't do, but I would like to bring it up, since we're getting down into pretty important like crypto material here and key materials, you kind of want that transparent view of what Kaleido is doing with regards to your keys. And you want to make sure that there's not another intruder or no one else is trying to make API calls to speak to that master key. So you can use CloudWatch, and you can set up an audit log, and you can actually get a map, or you can get a history of all the internal inbound and outbound API calls that are being made to that key. So essentially, you would be able to see this in real time, those calls coming from Kaleido. So that's a nice best practice, just something that I didn't quite get around to, but that's a combination of CloudWatch and just creating an audit log inside of there. So this guy, just like the node when we created it, when it's starting up, 20, 30, 40 seconds for it to fully initialize and rejoin the network. So as that guy's coming to life, let's go ahead and do some work on the KMS for transaction signing. So I will steal another picture in here somewhere. Bear with me. Okay, so this is the picture that we looked at last. And what we're going to look at is actually AWS KMS here, right here. So this is the mandate when you're creating your Ethereum key. So you had some liberties and you had some leeways when you're creating that master encryption key. It really just needs encrypt and decrypt. AWS for at least a year now, I think, probably much longer, has supported the Ethereum curve, which is SecP 256K1. So that is the only choice you can make when you're creating your Ethereum transaction signing key. You won't be able to see the plain text Ethereum address. Kaleido is going to actually derive that using a Go library under the covers, but we will show you that address inside of your Kaleido wallet service. So let's go ahead and get started on creating our configuration object for our KMS signing. And then we'll do the same thing. We'll basically stand up an HSM service inside of Kaleido, and we'll bind that HSM service to this KMS configuration object that we're making for signing. So I'll go ahead and get started on that. So now we're going to go down to cloud configurations, and I'm going to go ahead and make a cloud HSM configuration this time. Before I do that, I guess, sorry for all the hopscotching here. I'm doing a lot of things in unison, in tandem, but let's go back to our KMS instance, and this is the guy that we'll be speaking to this time. So we've taught Kaleido about the user and the associated secret and the region where our key vault, our KMS service is located, and Kaleido will just auto detect all of the keys that match that curve right there for us. So if I had multiple keys, multiple aliases, multiple SecP 256K1 keys inside of here, Kaleido would list all of those out for me inside of my HSM wallet that we'll see in Kaleido. I only have a single one. I think the prefix is like 0x3a or something like that. We'll confirm that here in a second. But what we notice specifically is that we need this to be, SecP 256K1 in order to do sign verify calls, our standard Ethereum transaction operations. Okay, so just showing the relationships again. So let's go ahead and add a cloud HSM configuration. We'll call this AWS KMS Ethereum signing. Again, doing my best to be intuitive. And now we need to choose the configuration provider. And we give you a rich set of options here. So we support AWS HSM clusters. That's a bit more involved, and you have to do some, certificate ceremonies, which some people like, others don't. I'm in the latter group, but recognize that X509s and certificates and PKI are very, very important. So we do support HSM clusters. Those are a bit more expensive on AWS. KMS is cheaper and simpler, so I'm opting for the KMS route. If you did want to do sort of this key management on premise, but maybe not do external signing or have this held in sort of the DMZ layer inside of your on-premise network, you can even leverage a HashiCorp server, and you can run this and operate this and stand this up yourself. And again, this will work with Kaleido's REST API gateway, or it'll work with just a standard Web3 application. And we support Azure as well, but today's about AWS. So we'll go with AWS KMS right here. And we see that all we want are those same three fields right there. We don't even need to give the ARN because, like I said, we're not talking about a specific key. We're talking about a whole set of keys that just match that Ethereum curve. So Kaleido is going to look in there and list all of those for us. So I want those same two strings, user ID and secret. We'll grab the secret first. And we'll grab that user ID. And again, this KMS service is in Columbus, Ohio. It's in US East-2. So I know this. And this is going to be exact same as the other one. This won't be exciting. This is just going to be, basically a non-live configuration object right here. So now what we want to do is we actually want to create an HSM wallet, an HSM service in Kaleido, and we want to take that JSON object, we want to take that config, and we want to marry them together. So I'll call this AWS KMS signing service. I'll deploy the runtime in Ohio in AWS US East. And now it's saying, hey, do you have one or more cloud HSM configurations available? If you don't, you're going to need to go create one, that step that we just did. If you do have it, you can just go ahead and choose from the dropdown here. So I'm going to click finish. This is going to marry those two things together. And when this service fully initializes, when this changes from yellow to green, from deploying to initializing to started, what we'll be able to do is we'll be able to click that wallet and we'll be able to see the derivation of this key that we just looked at right here, this SecP 256K1 key right here. So we can click into it, but we don't see terribly interesting information, right? We just see the alias that we created, the description that we did, the crypto configs, but we don't see that classic Ethereum address. So that's actually derived under the covers. So going back here, back into Kaleido, and what we're going to do here, what I'll ultimately show you is we're going to use this key and we're going to use our REST API gateway to sign some basic transactions. So I'll show that picture just to set the table super quickly. Again, apologies for hopscotching through all these different slides right here. I'll just use the docs. So what we're going to look at is we're going to look at basically running Ethereum transactions without any code inside of Kaleido. And we've looked at this in a lot of detail in the past, but ultimately what we're going to do is there's different query parameters, different headers that you can pass with your curl calls, with your REST calls. And one of them is say, hey, Kaleido, I want to sign with this key. So all you have to do is tell Kaleido about the associated Ethereum address for that private key held in KMS, held in that HSM cluster, and then Kaleido will do, all of the intercepts, all of the redirects, all of the, sequencing and signing and properly formed transactions, and submit those via Kafka into your network and return you that full transaction receipt. These can come in synchronously or asynchronously, completely up to you based on sort of your application logic and your business network needs as well. So I've already created a REST API gateway inside of Kaleido. So as this service is coming to life, we can just go ahead and take a quick peek at that. Gateway APIs. I used our old friend Simple Storage. which is so uninteresting that I'm not even going to revisit it. But just to give everyone a reminder, it has a single global variable that's a positive integer, and then has a set method, and it has a get method. The takeaway here is what we've done though is we've turned the API definition into an on-chain deployment, into a smart contract, and now we're able to use those simple post calls against the set method, or a get call against the query method, to update state or to retrieve state. Okay. So we've done a bunch of stuff right there. Now I want to turn into PrivateLink and look at some of those configurations as well. So let's go back to our blockchain, click on the dashboard. Let's do a quick refresh. This guy will be started by now. Don't know why it's not refreshing in real time today, but it's a live demo, so why would everything work perfectly? And similar to what we just did with the KMS configuration and with that HSM or cloud signing configuration, you do the exact same thing with your networking configurations in Kaleido. And I've named these intuitively so we can derive the fact that node number 1 is a hybrid node. It has a public ingress and it has a private ingress. And node 2 only has a private ingress, meaning that I can only speak to this node from within my EC2 instance inside my VPC with that Kaleido PrivateLink endpoint service configured and activated. So to create these configurations, it's the exact same flow. Cloud configurations, go to network control. We see that I have 2 of them. I could add a new one right here, Tech Tuesday example config. And then it's just going to say, hey, do you want this to be private? Do you want it to allow public? Do you want it to allow both? So very, very simple choices to make right there. One thing that I'll remind everyone on, that's a fantastic feature in Kaleido, is that every single piece of functionality that we expose inside of the dashboard has an API behind it. So there is an administrative, simple REST API for you to write your own cron jobs and for you to basically create your own admin dashboards and your own ops consoles. So yes, the dashboard is nice and intuitive, and it's a nice exposure of all the information and all the runtimes. But every single click, every CRUD operation that I do here, you can also do with an admin API. So just want everyone to be aware of that. Okay, so dragging my feet, I want to make sure this service came up. Okay, so this started, the configuration was good. So what we can do is we can actually view the wallet here, and I can click on the wallet and we see the derivation of that key. So my memory was good, 0x3a. And what we'll do is we'll use node number 2, our private only node, and we'll just send a couple simple transactions into that smart contract instance that we looked at. We'll sign one using the account that's held on the node, and then we'll sign one that's using this account where we're going to get that really cool, redirect into KMS, sign it, and then sequence it and send it back into your blockchain network. So we'll use that guy for one, and then for the other guy, we will use this key right here. The default, geth array 0 account that you get for free on your node. Okay, so now let's go into terminal land. Okay, so we want to take a look at a few examples here. So first, let's look at node number 1. So node number 1 was our hybrid node, which means that I'm going to be able to just send basic curl calls to the publicly accessible endpoint for that node. And then I can go ahead and SSH into my EC2 instance, and I can send private calls or use PrivateLink to access the private ingress of that node. Again, apologies for all the hopscotching. I just want to show the configuration that we have here. So inside my VPC instance, and conscious of the fact that we're running out of time, but this is well documented in Kaleido, and I know BJ did a nice job of walking through it. So you're going to create a VPC, launch that VPC, create an EC2 instance inside of it, and then you're going to create an endpoint for the Kaleido service. So we can see here that this is actually the service name that you would be searching for. If you have your node, in another region or another geography, the slight alteration becomes to this portion of the string right here. But since this EC2 instance, this VPC in my node is all running in US East, this is quite a simple configuration. The other thing to bear in mind when you're doing this is just the relationship of the security groups between your EC2 instances and between your VPCs. If you're using different security groups, you have to do some other steps in terms of allowing inbound and outbound connectivity for them to interface or for them to speak to each other. If you just use the same security group, then that becomes a lot easier as well. So ultimately what we're going to be leveraging here is this VPC endpoint service, which has PrivateLink under the covers to do some secure communication into Kaleido. So I just have some examples that I'll show here of what you can and what you can't do. So, okay. So the first one we want to do is we have a public endpoint for node number 1. This is our hybrid node. So I can just do a basic curl call right here. This is our application credentials, username, password. And we can see that there's a slight difference in the strings for the endpoints. So this is the public endpoint. And then if you're going via private link, via the private ingress, this is the slight alteration you need to make to the string, just US-East-2, basically the core location name, the naming conventions that AWS uses. So we'll just copy that, do a quick curl, and we should see a 200 response. We do right there, 200 is okay. And now we want to go ahead and hop into our EC2 instance right here, and we can go ahead and curl the private endpoint. And we should see the same response right there, a 200 response. But what we won't see, so we see 200 right there. Okay, so node number 1, our hybrid guy, he's cool, he's happy. Now let's go ahead and try to speak to our private only node from the internet, I guess right here, from outside of our VPC. So we can go ahead and try to curl the private endpoint, or we could try to curl the public endpoint. Either way, we're going to see a 404 right here. So I'll show an example of, I guess we can curl the private endpoint. We're going to see a 404. The takeaway here is that, if you create your node as private only, the only way you can communicate with it, is within your, VPC EC2 instance that has that Kaleido service endpoint configured. So this probably goes without saying that this will 404 right here, that, it's not going to find it, it's not going to access it. But if we make the exact same call over here, and I don't copy 404, then we'll see the 200 response over here. Okay, so this guy's happy. So I know, very 101 networking. BJ went into much more articulate details on how this works, and we're happy to talk offline in more details about your application architecture or any other questions. But just an example of what's accessible, what's not accessible based on your configurations. So the last thing we want to do is just send some transactions in. So first one we'll do is we'll just use that node account, the default Ethereum account that's on our Kaleido node, node number 2. So sign with this guy right here, 26C. So that would be this call right here. And you can see here, like this, thanks to the REST API gateway inside of Kaleido, this is all the code that we need to make. Like there's no SDK, there's no Web3 library, there's no sequencing, RLP encoding, nothing. That entire piece of middleware, the REST API gateway, specifically we call it ETH Connect, is going to do all of that heavy lifting for us. And we can see that the one parameter that we've set is this x-kaleido-from, where we're saying, hey, Kaleido, I want you to sign with this, this Ethereum key right here, this address. Everything's secured over TLS. So we have application credentials for every call, regardless of the fact if you're using PrivateLink. And then it's just a basic post call calling that method that I talked about inside the smart contract. So copy this right here. And this is going to be a synchronous call. So basically it's going to poll, it's going to wait for this to execute, and then we're going to be returned pretty lightweight JSON payload, essentially the transaction receipt that we have here. And we can see, in the from parameter that it was signed by that default account on the node. But now what we can do to wrap up the demo is we can use that private key that's held in the KMS instance right there. So if you marry all these together, you can get really, really high levels of security. We could use a node that has master encryption enabled. We could use a node that has only a private ingress, and we can, send in our transactions and sign them with keys that are held in an HSM service or a KMS service. So you can get, really, really far down the road in terms of all your security, all your different, key custody requirements. So again, the only core difference in this call right here is just the argument we're passing to that parameter right there. The other parameter to bear in mind is just this x-kaleido sync equals true. That means that we're polling, we're waiting for this response right here. TCP lookup, blah, 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 no such things. Okay, let's try this one again then. Live demo. I got so far down the road, the very last call isn't going to work for me. Let's try it one more time with our fingers crossed. Okay, so I've misconfigured something down here at the very end. We could use this same key inside of our Swagger interface. I could use it inside of Postman. For some reason, it just doesn't want to work right now. So apologies, but the core flow is the exact same. Yeah, that's okay. So I know we're a minute over here on the call. If there are questions or there are comments, I'll leave some contact information inside of the chat. I think VJ has done the same. Don't hesitate to reach out to us if you have any technical or commercial questions whatsoever. And we thank everyone for attending, and please stay tuned for some upcoming webinars, and we'll definitely have VJ and some colleagues from AWS back, hopefully in the near future here to talk about some more integrations and some more services.
Thanks, Nick. Thanks for having me here.
Thanks, VJ.
Bye,
Thanks,
guys.
everyone. Have a great Tuesday.